Diodes are some of the most common components in electronic circuits and devices, so it's important to understand what they do. In this video, we'll be exploring what diodes are, how they work in circuits, and the different types of diodes that you might encounter. So, what are diodes? Diodes are semiconductor devices that allow the flow of current in only one direction, which makes them useful for various applications, such as rectification, voltage regulation, and signal modulation. They are also referred to as rectifiers because they convert alternating current AC into direct current DC. This is accomplished by allowing current to flow through the diode during the positive half cycle of the AC signal, while blocking out the negative half cycle, resulting in an output DC signal with much higher voltage than the input AC signal had originally been supplied with. What are the different types of diodes? Various types of diodes exist, which serve different purposes, but all have a primary function in common, allowing current to flow in one direction only but not in both directions simultaneously like other electrical components do, such as resistors. Examples of some of these types include Zener Diodes, Schottky Diodes, light-emitting diodes, LEDs, and photodiodes. Let's take a closer look at some of these diodes and learn more about them. 1. Rectifier diodes. How do they work? As mentioned previously, rectifier diodes are utilized to convert AC power into DC power by allowing only positive voltage peaks through while blocking out negative voltages that could potentially damage sensitive electronic components or systems that draw their power from DC sources only and not AC sources. The diodes work by forming a bridge between two terminals on either side of an electrical circuit. When forward bias with electricity entering from one side, then leaving via another side after passing through the diode's junction barrier and getting rectified. This enables DC power to be drawn from an AC source without any interference from unwanted voltages or frequencies that could disrupt or damage other components connected to it. Applications. Power supplies used for numerous applications often require transforming AC power into DC before it can be used. This is where rectifier diodes shine, as they make this possible efficiently and reliably by preventing negative voltages from interfering with other components present in the system, while allowing desired positive voltages to pass through unhindered, thus providing clean, uninterrupted DC power output when supplied with adequate AC input signals at regular intervals and cycles. 2. Light-emitting diodes. An LED is a semiconductor light source that emits visible light when an electric current passes through it. LEDs are typically made of gallium, arsenic, and phosphorus, or a combination thereof, and can produce light in different colors depending on the materials used. They are highly energy efficient and do not require any additional components, such as a heat sink or cooling fan, to operate properly. 3. Zener Diodes. A Zener diode is another type of diode that is operated in reverse bias and can provide a stable reference voltage. Zener diodes are often used in voltage regulation applications, where their low forward voltage drop provides more efficient power dissipation than other diodes. Additionally, Zener diodes have the ability to protect against overvoltage conditions by clamping the output voltage to a safe level. 4. Schottky Diodes. Schottky diodes have a lower forward voltage than other silicon p-n junction diodes and are commonly used in rectifier applications such as AC to DC converters and motor drive circuits. They have very fast switching speeds due to their low capacitance values, which also reduces power losses in high-frequency switching circuits. 5. Photodiodes. Photodiodes are reverse bias diodes that detect even small amounts of current flow resulting from light exposure and can be used for sensing motion, detecting radiation levels, or measuring ambient lighting conditions. They typically consist of two layers of semiconductor material joined together, with one layer being heavily doped while the other is lightly doped, so that when exposed to light, electrons are injected into the lightly doped layer, creating an electrical current, which can then be measured or used as part of another circuit, such as an amplifier circuit. And lastly, laser diodes. A laser diode is an incredibly powerful and efficient semiconductor device that produces light through a process called light amplification by stimulated emission of radiation, laser. This process involves exciting electrons in the device using electric current, which causes them to emit photons of a single frequency. All of these emitted photons travel together in phase with one another, producing an intense and highly concentrated beam of coherent light that can be focused onto very small spots. The use of laser diodes has become increasingly popular over the years due to their size, efficiency, and ability to generate beams of highly concentrated energy. They are used extensively in applications such as laser printers, barcode readers, security systems, and even medical treatments. Due to the unique physical properties of the light produced by laser diodes, they are also capable of transmitting data over large distances with minimal distortion or interference from other sources. This property has made them indispensable for optical telecommunications links and free-space optical communication networks. Additionally, some types of lasers can even be used as remote sensing devices to measure distances and analyze terrain features on Earth, as well as explore distant objects in space. In summary, laser diodes are an invaluable tool for engineers looking for new ways to create highly focused beams of energy or to transmit information over long distances with minimal interference. As technology progresses, we will undoubtedly see even more uses being made out of this amazing piece of hardware. So we can see that diodes are essential components when it comes to powering electrical circuits, especially those involving sensitive electronics, due to their ability to convert AC power into DC reliably and efficiently, along with providing a means for limiting and clamping voltage levels at desired values which protect downstream components. For more helpful videos like this, be sure to hit the like button. Subscribe to the channel if you haven't already, and turn on the bell notification so you never miss an upload. Thanks for watching. Catch you guys in the next video.